Hello, ladies and gentlemen. We're going to do 11.3, the cross product of two vectors. The objectives are that we're going to find the cross products of our vectors in space, and this is our last video of the year. Woohoo! All right. In the real world, physics, engineering, geometry, people need to find a vector that is orthogonal to two given vectors. So remember that orthogonal, cool word, means that two vectors are at right angles. Okay, so remember in our three-dimensional system, because we're talking about in space, these two vectors are orthogonal because they are at right angles. These two vectors are orthogonal, and can I draw it? Can it hurt my head? Those two vectors are orthogonal because they are also perpendicular. Alrighty, so there's a cool example in your book about a bicycle chain. So here's my ring, and then I have my pedal, okay? And then there's going to be my pedal. And I have a crank arm, and so I need the crank arm to be perpendicular, and so it's all kinds of cool math involved in cycling. Alrighty, so let's talk about the definition of cross products of two vectors in space. Okay, and so anytime, remember, we see that lovely little prepositional phrase in space, that means that I have 3D stuff going on. Alrighty, so if I have u, the vector u is going to be I, and then u sub 2j, and u sub 3k. And then v is going to be v sub 1i, v sub 2j, and v sub 3k. So I'm writing both of my vectors in standard unit vector form. So I'm going to write standard unit vector form. Okay. Alrighty, and so remember, I could also write this as a number in each of the three locations, but I have this is component form, two very specific ways to write vectors. So today we're going to manage our unit vector form, and at one point in the problem I'm actually going to switch to this form, and then I'll go back to this one. Alrighty, so if I want to do a cross product, you're going to laugh, there's my cross product, okay, and that is going to be u cross v, and that is going to give me this lovely mess. So it's going to be u2 v3 minus u3 v2 times I, gotta sneeze, minus, sorry, and then I'm going to have u1 v3 minus u3 v1 times j. And then I'm going to have my u1 v2, u2 v1, and k. And at this point, besides not being able to see, you're probably thinking, holy crap, Bane, what the heck? But this is really actually not as bad as it looks. So I'm going to ask you to think determinants. And if you'll remember back a million years ago when we actually did our matrices and we talked about cofactors and blah, 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 that's basically what this is. So it's actually much easier to manage than it looks. So let me show you this. So let's say I have u cross v, and I'm going to put it in a vector, in a matrix that looks like this. Wrong math word. u2 and u3. And I'm going to want to calculate the determinant. So here's v1, v2, and v3. So these are, the components of u, and these guys are the components of v, and I have them in I, j, k form. So remember, if I'm going to calculate the determinant of this lovely little matrix, okay, I'm going to kind of put a circle around it. That's what your book did. And let me bring in a different colored pen just for the first one. So if I want to manage the I, I'm going to eliminate those two rows. So this is going to be I, times the little matrix that's left over, U2, U3, V2, and V3. Okay. sorry, and then here's going to be j. Notice that it's a minus j. So if you think about this guy, I think it'll just confuse you. If I put a little circle around this guy, and I eliminated this way and this way, the matrix that I would have left would be U1, U3, V1, V3, and then I'm going to add K, and I would do the same thing, eliminate this row and this column, and I would have U1, U2, V1, V2 left over. So remember, the little absolute value bars mean find the determinant, so this is going to be I times, sorry, this minus this, this minus this, this minus this. So that's where I get the U2 V3 minus V2 U3. J is always minus because, and remember, in a 2 by 2, when I'm calculating the determinant, I subtract that second value. Sorry, I think I'm dying. U1 V3 minus, oops, those are supposed to be curved brackets, V1 times U3, and then plus, and then here's my last one, K times U1 times V2 minus V1 times U2. Well, it looks so much better when we use real numbers and less U's and V's, okay? So now let's do, now let's do an example. Alrighty. Oh, except my paper's stuck. Alright. So let's say, in our example, I'm going to be given that U is equal to I plus 2J plus K, and V is going to equal 3I plus J plus 2K. Alrighty? Whew, that's furry. Alright, so I want to find U cross V, and then I want to find V cross U. So remember that cross products give us orthogonal vectors. And remember that orthogonal vectors, those are a mouthful of words, has a dot product of 0. Alrighty, so let's just find the cross products first. So if I do U and V, so U cross V, I'm going to put my I, J, K at the top, and put my little bars, and then I'm going to put U in the second row. The order is important because of the way that we're managing the order of our cross product. So this is going to be 1, 2, and 1, and I'm using the coefficients of the individual components for my U vector, and then I'm going to do 3, 1, and 2. Okay? So if I just eliminate this guy, it's going to be I times, and I'm going to have 2, 1, 1, 2 left, minus J, it's always minus J, and if I eliminated first row, second column, 1, 1, 3, 2, and then plus K, eliminate first row, third column, I get 1, 2, 3, 1. Now I'm actually going to calculate those determinants. So it's going to be I times 4 minus 1 minus J, and remember I'm doing this multiplication and subtraction, so 2 minus 3, and then K times 1 minus 6. So if I do this math, I get 3I plus 1J minus 5K. And so this would be my cross product of U cross V. Okay? And if I wanted to put it in component form, I could write 3, 1, negative 5. Okay, so remember there's two different ways to talk about vectors. Alright, so now let's do our second part of the problem. Let's do V cross U. So again, sorry, Spring and Flagstaff. I'm going to draw my IJK at the top, and then I'm going to put the V vector next. So I'm going to have 3, 1, and 2, and then 1, 2, and 1. And those are the coefficients for my unit vector pieces from the original vectors. All right? So if I eliminate first row, first column, I'm left with I times 1, 2, 2, and 1, always minus J. So I'm going to eliminate first row, second column, 3, 2, 1, 1, and then plus K. eliminate third row, sorry, third column, first row, and I'm left with 3, 1, 1, 2. Alrighty, so now I'm going to do the determinants of those. So it's going to be I times 1 minus 4 minus j times 3 minus 2 plus k times 6 minus 1. And so I'm going to get a negative 3i minus 1j plus 5k. And this is v cross u. Alrighty, and if I put it in component form, it would be, a negative 3, negative 1, and 5. Well, if you'll notice, this is kind of cool. This cross product is identically opposite that cross product. So if I have u cross v, that's the same thing as doing a negative and then v cross u. So a handy dandy little property to throw in there. Okay, helps if you can see it. All right, so I do have a couple of properties to tell you. So geometric properties of the cross product. Okay, number one, if I have u cross v, that means that it is orthogonal, which means they are at right angles. Okay, I'm just going to stick in my little Greek hieroglyphics, my geometry hieroglyphics, to both u and v. So let's have a little picture. Okay, so think about our three-dimensional coordinate system. Okay, if I have, wrong letters, x, y, and z, and I have a unit vector, remember, with a magnitude of 1, going in that direction, and then I have a unit vector going in this direction as a j, and a unit vector going this direction, there's k. And remember that those guys are all orthogonal. Ooh, this one hurts my head. Okay, alrighty. It also creates a little rectangle. Alrighty. Okay, number 2. My next property says the magnitude of u cross v is the same thing as the magnitude of u times the magnitude of v sine of the angle. Okay, alrighty, so that's kind of entertaining. Number 3, so I could actually solve for the sine of an angle, or I could solve for an angle if I wanted to. I know that u cross v is equal to 0 if and only if u and v are scalar multipliers of each other. So if I scale one, it would give me the other and vice versa. Okay, and then my last one is that if I want to do the magnitude of u cross v, that's going to give me the area of the parallelogram in my handy dandy little picture up there that has u and v as adjacent sides. Alrighty. So again, we're just going to do just enough in this chapter to be dangerous. We could start doing some really cool stuff. Ooh, can I draw it? Maybe. We could actually start talking about, maybe I can, calculating the volume of a weird word by doing a process of cross products. So we're going to skip that at this point. But that would be another extension of what we're learning. All right, next example says find a unit vector that is orthogonal to both u is equal to 3i minus 4j plus k and v is equal to a negative 3i plus 6j. There's no k component, so remember that means that piece would be 0. All right, so the first thing that I want to do is my cross product. So u cross v would be an orthogonal vector to both u and w. Sorry, u and v. Bad handwriting. So let's do u cross v first. Okay, so I'm going to drop it into, I'll write u cross v, and I'm going to drop it into my I, j, k determinant matrix. So u comes first, 3, negative 4, 1, then negative 3, 6, and 0. So this is going to be I times negative 4, 1, 6, 0, plus, minus j times 3, 1, negative 3, 0, and then plus k times 3, negative 4, negative 3, 6. Alrighty. If I do that math, it's going to be I times 0 minus 6 minus j times 0 plus 3. Make sure that I wrote it down correctly. I did, because that's a negative, really bad handwriting. And then plus k times 18, that's a plus 12 minus 12. Okay, so if I simplify that, now I have negative 6i minus 3j and plus 6k. And that's my orthogonal vector. Okay, but now what I need to do is find a unit vector. Alrighty, so remember, I need to find my magnitude. So I'm going to do the magnitude of u cross v, and it's going to be the square root of a negative 6 squared plus a negative 3 squared plus 6 squared. And remember, I'm finding the magnitude of the dot or cross product, not the dot product, but the cross product. So this was radical 81, and that turns out to be 9. Now I can do my unit vector. So remember that a unit vector would be u cross v divided by the magnitude of u cross v. So this is going to be my negative 6, negative 3, 6. This is what I'm jumping back to component form. And I'm going to divide it by my magnitude of 9. The book likes to write it as 1 over 9. Pull that out front, and negative 6, 3, and 6. I like to put them all together, negative 6 over 9, 3 over 9, 6 over 9, and reduce my fractions. So I'm going to end up with a negative 2/3, a negative 1/3, and a positive 2, negative 2/3. And then we can write it in standard unit vector form. So it's going to be a negative 2/3 I minus 1/3 j minus 2 minus, that's a plus, did I do that right? I did. Plus 2/3 k. Alrighty, and that would be my unit vector for the cross product. It's orthogonal to both. So I'll just write this as like that. Alrighty, and that would be my solution. So not too difficult, just weird enough to kind of mess with your brain. Alright, so let me give you your problems. Last set of problems for the year. Woohoo! Alrighty. I'm going to give you that u is equal to 3i minus j and 4k. And I'm going to give you that v is 2i plus 2j minus k. And I want you to use the vectors u and v to find. So number 1, you're going to do v cross u. Remember, the order is important. Number 2, you're going to do v cross u. Number 3, you're going to do u cross, and then I have a scalar times v. Okay. Number 4, I want you to find u cross v and show that it is orthogonal. Remember, if for two vectors to be orthogonal, their dot product is 0, okay, to both u and v. So you would need to show me that the cross product, when I multiply it by u, I get 0, and when I multiply it by v, I get 0. Alrighty, last problem. See if I can scoochie it up there. Problem number 5 says find a unit vector orthogonal to u and v. And I'm going to know that u is equal to 7I minus 14j plus 5k, and v is going to equal 14I plus 28j minus 15k. So on this last problem, so once you see it, I usually write mine and distribute the values. I just think it looks nicer because it's easier to reduce your fractions. So this would be the way that I would like you to write your solution for problem number 5. All right, so good luck with your problems. There they are again. I think you can see all 5, and I will see you tomorrow.